This is again a continuation session of transport layer. In this session, we will try to understand one of the key responsibility or feature of transport layer. Transport layer, that is congestion control. Okay. So what is congestion control? Have you ever wondered why your downloads, right? If you are downloading, why your download don't always max out your bandwidth? You might be using 150 Mbps internet connection, but your download doesn't start with even 100 Mbps speed. Why does this happen? Or why your network performance can suddenly drop and recover after some time? So if you are experiencing this, right, then you are in the world of TCP congestion control. So congestion control is about balancing. It's a balancing act, balancing throughput, throughput and network stability. Stability. Okay. So TCP tries to send as much as data as possible without overwhelming the router or causing massive packet loss. The trick here which TCP uses is constantly adapts its sending rate. Okay. It constantly adapts its sending rate based on the feedback which it keeps on getting from the network. Okay. So just imagine now, okay, there is a highway. There is a highway. You are taking your vehicle to the highway. Okay. Now as soon as you start, right? How do you start? You start slow in the beginning, right? You start slow. Then you realize that okay, the highway is fully empty, yeah. So I can raise my speed. So you raise your speed. Raise your speed. Correct. Then you realize that there are multiple vehicles on the road. There are multiple vehicles on the road ahead. So you adapt to the congestion avoidance. So wherever there is no congestion, you try to avoid those, right? And as soon as you again land into the proper no congestion zone, right? You quickly raise your speed and cover up the distance, right? So that's how in real life you work. And the similar way, the digital world also works. So congestion control TCP also work the same way. So for TCP, our network is a highway. This is a network. For TCP, network is a highway. Packets are the cars which are going through this network. TCP ensures you don't overload the network. You don't end up with sending lot of cars which makes the network congested. Okay, so why congestion happens? Let us try to understand that. What are the reasons of congestion? Why congestion happens over network? Why congestion? Okay, so congestion happens because too many people are using devices. They are keep on sending packets, and there are congestion, right? And at the receiving end or at the router end, the router is overloaded with the packets. So it cannot, it has a queue for processing because it has some limited rate of processing. It cannot process more than that. So there is a lot of packets getting accumulated around the router. Okay. So it is so much that the buffer, whatever the router is having for processing, right, that also will get full. So that is another reason for congestion. And in congestion, what happens? some of the packets get dropped, right? Because it's congested network. Similarly, in your highway, right? If there is lot of congestion, some might meet with accidents, some might fall, right? So some packets will get dropped, and the result of all this tragedy is network slow. So who will prevent all these things? Who will prevent this network congestion? So it's a TCP who will prevent it. Okay. So TCP will provide your network collapse. Your network should not get collapsed, because if it get collapsed, your all internet will stop, right? TCP also prevent the packet loss because it has to deliver the packet, right? So it also has to prevent the latency increase, right? It has to deliver the packet in the optimum performance way, right? So it has to prevent the latency. So all these things, it will work out with the help of congestion control. So how does TCP does this magic? So TCP controls the speed of sending packets by adjusting the congestion window. There is a concept called congestion window. It uses this. It is also CWND short form. Okay, based on network condition. So it looks at the network, how busy is network, and it will arrive at the congestion window, which is the slowest congestion window, right? If network looks free, then send faster. If network look congested, then slow down. If it is slow down, your congestion window will be less. If network is free, congestion window will be more. So how TCP starts, right? How the packet starts sending. So it start this way. Similar way, what the example I given. If you go to highway, right? So the similar way, TCP starts slow. So it will send one packet. Okay. If it receives fast and it receives the feedback that there is no congestion, it will double up the speed. So if it is sending one packet at a time, it starts sending two packets at a time. If it is again receiving fast, it will again send three packets at a time. So that's way it will exponentially grow its rate of sending the packets. Okay. At some point of time, TCP realized that there is a congestion. So there are lot of congestion. Okay, so what TCP does it? Instead of exponentially growing, it started growing incrementally. For example, 16, 17, 18, 19, this way it will start growing. It doesn't grow from 16 to 32 to 64. It doesn't grow like that. It grows linearly if there is a congestion. And it also detects that if the packet is lost in the middle, right? Now for this you need to understand one concept, that is, for example, so this is the sender, this is the receiver. Okay, so we have seen the CWND, congestion window, right? So usually the value of this congestion window, it will be 3. So what happens is, as soon as the data sending starts, right, 3 packets will be sent. Okay, 3 packets will be sent. Okay, and as soon as it has received here, right, the acknowledgement will be sent back. Acknowledgement will be sent back. ACK acknowledgement, right? So this is how the CWND works. Now what happens is, when CWND, for example, reach to 4, now it has sent 4 packets. 4 packets. 1, 2, 3, 4. Now this guy receives only 1, 2 and 4. So it will send that it has received. What about 3? 3 it has not received, right? So what happens is when every packet is sent, there is an expiration timer. Within this timer only there should be an acknowledgement should come. Okay, that is one concept here which you need to understand. In case it doesn't receives, right, the acknowledgement, the sender, this is send, right, this is receive, the sender will resend it. And sometimes what happens is you send a multiple packets at a time, but what happens, the third is not received here. So what happens is as soon as 1, 2 and 4 received, right, the receiver will send one more message telling that I am waiting for, I received the out of order packets, I am waiting for the packet number 3 sequence number. Okay, as soon as the sender receives this, right, it quickly retransmit it again. So sender quickly resend the packet, it doesn't wait for timeout. Okay, so this is one of the concept here. This makes us faster recovery. This allow us to do faster recovery, means the packet third doesn't receive, but as soon as it receives a message that it has not received, it will quickly retransmit it without waiting for expiry. This allow is to do a faster recovery. So this is the concept of congestion control. This is how the congestion control works. So what all are things we have seen? We have the important thing is CWND, congestion window. You would have heard windowing algorithm, right? The minimum size which is kept is 3. 3 is like a not a minimum, not a maximum, and it is very easy to recover the loss at the early stage, right? For example, if you are sending 10 packets at a time and there is a loss at third packet, correct? So it is much hard to recover this loss quickly, right? So if it is less, right, it will be quickly recover. So that's how, and quickly recover and quickly manage also. So that's how the size is kept as 3. Okay, so that is all about the congestion control.